Alright, so this video, section 2.1, it's all about limits and rates of change. I toyed with not making this video, kind of coming at it from a different standpoint, and quite honestly, if this was in a class situation, when I was in class with people, instead of online, where I can guide, I suppose, guide things a little bit better, you know, in terms of, okay, this is exactly how I want you to do things, and this is what I want, and I can meet you in class, and we can talk about things. I probably wouldn't do this as a separate unit. I don't normally when it's in class. So what I'll do is I usually talk about this at a later time, but I'm going to do it right now. So here's the game. We're going to talk about rates of change. Your book always simplifies that or abbreviates it as ROC, rate of change. Okay. Really what that is a slope. I mean, that's all it is. So, you know, as we mentioned before, I think, I can't remember which video this was. Isn't that funny? You teach about 100 videos, you're like, which one is this one? But anyway, you know, if this is you driving somewhere, okay, this is where you ended up going to. And let's say it's 500 miles away. 500 miles. And print right here, let's say it took you 10 hours to get there. So your average rate of change. Now you gotta be careful because that is rate of change. When I say that, I have to specify an interval from 0 to 10. Well, that would be 500 miles minus 0 miles. So it's a change of 500. And I had 10 hours to do that because this is the point 10 comma 500. And this is the point 0, 0. So of course that's 50. However, had you done it from here to here at, say, I don't know, 1 hour and 2 hours, and this is 30 miles, and that's 60 miles or something, then in that region, then you would say something like, well, that's the point 130 and the point 260, and then you do some slopage, and then so it's 60 minus 30, 2 minus 1, so your slope would be 30 there. Interestingly enough, from here at a half, you see, which is obviously 40, duh. Down here to 1, well, that would be at a half, comma 40. So your average rate of change from there to there, well, you came back 10 miles, and you did it in a half an hour. So it's negative 20 miles per hour. And again, rates of change, pretty easy to do. Those are all averages. Because you could have done other things between here and here. You did not necessarily drive on a straight line. Clearly, you did not here at all. And here, not completely a straight line. Like from here to here, that is not a straight line. You took this circuitous approach. Okay, but the slope of this line would be the average rate of change across there. And average rates of change are pretty cool and they're very useful. I mean, obviously we use them all the time. However, what we're going to be more concerning ourselves with is instantaneous rate of change. If you've ever gotten a speeding ticket, at least in the West, if you go back east, maybe not so much, but I mean to some degree because they have toll roads. But out here, if you get busted for speeding, you got busted on your instantaneous rate of change. Okay? How fast were you going right now? And the idea here is this. Here's some random function, whee, and you're here, and let's say, oh, I don't know, here. Okay. If you drew like that line through there, the average rate of change from there to there is clearly positive slope. Okay. Now, let's call this x equals 2. Maybe this is over here at x equals 3. And so you could get some points and you could find the slope of that line. That's easy. But that's over, if that was an hour, I mean, geez, what can happen in an hour of driving? Well, a lot. What can happen in a minute of driving? A lot. And so what we're going to talk about today a little bit is the idea of, well, can we get an approximation for an instantaneous rate of change? And so I will give you a function. And I'd like you to estimate the instantaneous rate of change at x equals 1. Well, that's interesting. So, the way I was taught back in the day, before, calculators, when, old people ruled the roost, we were told to plug in our values. So the value in question is 1, you get 3 out. And then we were told to plug in values on either side of it. So plug in 0, that's the other side of 1. And you get 2 out. And then plug in another value like this. So 2 squared is 4 plus 2 is 6. And so the way we do this is we say, all right, well, let's find the slope, okay, from 0 to 1. So the slope is 1 across that region. Make sense? Now, the slope from 1 to 2 is 3. So what you're saying is if you were, oh shoot, if you were to graph this guy, it looks like this. Whee! And here's this point, and here's that point, and here's this point. So what you did is you found this rate of change here, and this rate of change here. What do you do when you have two numbers in a math class and you don't know what to do with them? I know. Let's average them. Good idea. So 1 plus 3 divided by 2, well, 4 divided by 2 is 2. And this is your approximation for the instantaneous rate of change. And now you're like, well, but that's still a long ways apart. I mean, even if these are minutes, that's a long ways apart. So the question might be, well, could I do better? And of course the answer is, of course you can. One way I like to do it is I like to use Excel because it makes me happy. I'll show you on a calculator here in a minute too, so just relax. If you don't like Excel, totally fine. Okay? If a person was keeping track at home, they might go, well, here's X, whatever, and then here's my Y over here. It's the same deal I just did. And so, we plugged in, I'm going to do 0 here, I guess. And then I'll just do 1 and 2 just for fun. Oops, not 1 and 12, you dummy. So over here I'm just going to say equals, because that's what you got to do. So here's your x squared plus 2. And then you just click on the corner of it here and drag it down. Nice. And so if a person wanted to find the slopes, the person could do this. Alright, that minus that, parentheses, divide by, parentheses. Why wouldn't you just type it in, Jay, or do it in your head? Ah, friend, I'll show you why. Okay? Because now that formula can be drugged down. And then over here you could do equals, parentheses, that, give it to me, plus that, divided by 2. And you're like, well, Jay, come on now. You can do better. You're right, I can. I could choose 0.9 and 1.1. Those are a lot closer to x equals 1. That's what I'm interested in. And everything updates, and look, the slope is still 2. Now, in this case, you're like, well, I can do better. I know you can. I know you can. I have faith in you. Looky there, friends. And it turns out that this particular one we just did, actually, that is the instantaneous rate of change is exactly 2. And so that would be your good estimate because it would be it turns out it's the exact value. Now, I'll whip out my calculator here. You can do it on the 83s and 84s and 89s as well. So here's a TI-89. If I'm doing this on an 89, I'm going to go to y equals. Clear anything that's in there. I'm going to go x squared plus 2. Okay. And if you look on F4 right there, you'll see it says table set. You only have to do this one time. Okay? Yours undoubtedly looks like this. That's the default. It'll look something like that. I come down here to auto, or where it says independent, and I put it on baby on ask. And I hit enter. And there it goes. Now I go diamond F5. Takes me to the table, and here's where I can put in 0 and 1 and 2. Oh shoot, just Just a minute. I get carried away sometimes. 0, enter, down. 1, enter, down. 2, enter. There you go. Cool. Now, the idea here is that you'll still have to do those calculations by hand. Okay, it's not hard to do them by hand, but, there's the numbers. You can get to them quickly. Okay, so whatever. If you have a TI-89, you want to use it. Well, I have a TI-83 or 84, Jay. Cool. Oh, stupid. Let's try that again. I was going to do this. TI-83. This and the 84 are identical in terms of how they work. So if you go to y equals, clear that garbage out of there. Just hit clear. Now just go x squared plus 2. And then you look on top of the window button, you'll see table set. And again, the default is auto right there. Just come over, hit ask, like that. And then now second graph. This pops up, and then you can put in your values. 0, 1, 2, etc. You could do, of course, 0.99, 0.99999, or whatever. Oh, well, that's kind of ridiculous. I didn't see the extra there. There we go. And so on and so forth and so on. You still have to do the calculations by hand. I like Excel for the fact that I don't do all the dumb calculations by hand. I find that a little annoying. A little, I don't want to say beneath me, but yeah, a little beneath me. I can add and subtract. I don't have to prove it every day. I'll have the dumb computer do it for me. Okay? Now, of course, you can do the same thing here, and you're like, well, I don't know, f of x equals e to the x. Okay? And you would like to find the instantaneous rate of change when x equals 2. All right. So again, the idea here, x and y, and 2, and then I would do like 1 and 3, I guess, right? And then you build up to it. Okay. Of course, that's e to the 1, e to the 2, and e to the 3. I mean, obviously, but that's stupid, right? They're actual values. Now, this is why I like Excel, because, well, it doesn't take a whole lot of brains to figure out how to run the thing. That's good for me. So, I'm going to put a 2 right there, and I don't know, probably a 1.99 right here. The thing that people make mistakes on these guys is that they, actually, I don't want to do that. I want to do 1 and 3. Now, you're like, those are the same numbers. That's right, because we didn't change the function. Okay? Now, the function is, in Excel, it's e to the x is exp of x. Whee! And you're like, wow. Look, Jay, from here to here it was 4.67. From here to here it was 12. Boy, that's a lot. I mean, the average is 8.6, of course, across there, but I feel like we can do better than that. Okay? And of course you can. Of course, the closer you inch those points to 2, the better your approximation, of course, is going to be. Oh, well, what just happened? Oh, for God's sakes. How about you put it in the right spot, dummy? Nope. There we go. I bet it works now. Oh, look at that. Dog. 7.3, 7.4. Average 7.389. That is a pretty good average. Okay. Interesting, friends. Look at that. And look at that. Look at this. And look at that. This is approximately the rate of change at x equals 2. This is e of 2. What? Jay, are you trying to tell us something? I am. I'm going to spill the beans right now because I can't keep a secret for sour beans. So, I'm going to tell you right now. The derivative, which you don't know what that means yet, but the derivative of e to the x is itself. And so that is why this guy right here basically matches that guy right there. Okay, it's pretty slick. And so, I noticed I went out 2.001. It just said screw it. I'm going to round it off to 2. That's cool. Okay. But that's the idea of it. That's all you're doing really in that section. Okay. Now you're like, well, what if the book gave me a map? I mean, a map. What am I doing? A graph. Whee! And you were able to count over to 1, comma 3. All right. And, I don't know, here at 2, you were down here at, I don't know, 2.5, whatever. And at, oh, I don't know, right there, you're at 0, comma 2.75. But interesting to note, you could find this from here to here, right? You could just pick that right off the graph and go, all right, well, 3 minus 2.75 over 1 is about 0.25, right? And then you would do 2.5 minus 3 over 2 minus 1, which would be negative 0.5. And if you average those together, you're going to get 0.25 minus 0.5 divided by 2. What you're going to find is that's negative 1/4 divided by 2 is negative 0.125. That's awful close to 0, friends. And if you think about it, right here, instantaneously, if this was distance versus time, right there, he ceases to go anywhere outward. He was going away. He stopped just momentarily. He turned around and came back. Well, what is the slope right there if it's not changing? Slope is 0. Would it make sense that when we did an approximation that it's somewhere near 0, like negative 0.125? Yeah, that makes sense. And so you're going to be doing some of that on the homework. You're going to be looking at just doing a lot of approximations. Whether you use Excel or whether you use the calculator is neither here nor there to me. I just don't care really one way or the other. Oh, by the way, if you're on the graph right here, you can click on second trace and you can type in, just hit enter for value. You can type in value right there. It'll tell you the X and the Y point. That's something that you can do if that makes you happy. Same thing can be done on the TI-89. I just like to use the table. If I'm not using Excel, I like to use the table feature. I find it to be, cooler, I guess. Same thing here. If you hit F5 for math, value, just type in 2. There it is. Okay. So you're welcome to do that. But again, I would just use the table if I wasn't using a spreadsheet. And I don't work for Microsoft, so if you have a problem with Bill Gates and you want to use the other billionaires' software, Google Sheets, you can knock yourself out. I don't care. It's just a way to do the math in a quick hurry, I think.